Welcome to the Meltzone Podcast, recorded on June 14th, 2021. This is episode 47. I'm Tom.
And I'm Stefan. And topic for today's podcasts are Tom's, streaming marathon, building his VORON 2.4. We are famous because we have been featured in Make Magazine Germany. An entry from the German Jugend Forscht, putting ultrasonic, emitters to a resin vat for heating the resin and dispersing it for better printing quality and also better strength. And a quick update on the Torshn Kickstarter that has been suspended.
Yay! And sticking on the topics of more Kickstarters, we discuss a Kickstarter, a 3D printed bike helmet, the calf helmet that is printed entirely from TPE. Can that work? I don't know. And answering some questions today as well about the watertightness of 3D prints, whether a FDM print or a resin print can be watertight at all. Availability of Siraya Tech, that's just a quick one. And how our experience has gone so far with the Duet boards and whether they are suitable for using as an Octoprint replacement.
So how burned out are you after your 6 live streams?
7 actually now
already.
I think yesterday was the 7th. Yeah.
Oh. So how burned out are you?
Well, the thing is, if you have a live stream every other day and you do like other stuff between those live stream days, just to prepare for it and to do stuff off camera to get the machine ready for the next live stream, that kind of puts you on a weird rhythm. Because I guess it's the same for you, but live streaming, when you're actually building something and when you live stream it to camera and not, with a video game entertaining the viewer and you just make a comment every now and then, that is one of the most exhausting things that I'm doing. So yeah, 3-hour live stream, that's basically the entire day taken and used up. So I do appreciate that moment, or I do look for that moment when it's all built and it's all working, and that hopefully is going to be, maybe the day this podcast airs, on the 15th. So that would be live stream number 8 with everything going. By the way, I'm going to switch you away real quick. There is the VORON that we're talking about, the VORON 2.4 that I'm building in a live stream series. Okay.
How was your experience so far? Because, we gotta say, you streamed 7 times for on average 3 hours. Yep. That's already a good 20 hours of building. Yeah, you were streaming also, which takes up some time and concentration. But how was your experience building it?
Pretty good. I mean, obviously I've built printers before. If it's first time building a printer, it will probably be a bit different, but it's pretty good. Like, the manual is really well done for the most part. Like, you can see it's not like super in depth like a Prusa manual that tells you every step 3 times. It assumes you kind of know what you're doing. But so far everything fits really well. Everything is logical, more or less, and it goes together really well. I guess the biggest positive experience was yesterday in the stream when I got the firmware configured and everything just worked. Well, I did have to swap around a couple of axes and stuff, and the thermistor setting was wrong, but that's minor things that are expected. But there was nothing that was binding. There was no motor that wasn't working. There was no issues with the setup. It just worked, which is pretty amazing for a printer you've spent, I guess combined almost 30 hours now with all the stuff I'm doing off camera. The fact that there's no significant mistake in there is pretty uplifting.
Cool.
And
so
it is fast.
It is fast, yeah. So I'm sorry I haven't followed the whole
no worries, you've got better
7
things to
streams
do.
so far, but I came by a couple of times. I have seen you just jogging it around yesterday pretty fast.
Yep.
I think you haven't printed anything with it yet.
Correct.
Will this be the big goal for your next stream?
Yeah. I mean, because that's all that's left to do. Well, except for the stuff that I noted down that I still need to do off camera. Tie up a couple loose ends. Like I missed inserting the PTFE into the extruder. Happens. Homing still needs to be configured. Setting a nozzle offset, calibrating the extruder, like those things that are just futzing around and kind of figuring a couple things out that I don't want to subject the stream to. Those I still have to do, but yeah, pretty much that's that. All the axes are functional. The extruder is heating, or the hot end is heating up. Everything works on this machine. So the only thing left to do is set up a slicer profile and get printing. What speed should I start at? Should I just go straight to 200 millimeters a second? Not even
the question is, what material will you be using for like your first print?
True. I guess PETG then, because PLA is just going to be a melty mess.
Even with PETG, it's kind of hard to get not a melty mess at these temperatures. So my experience so far, printing at really higher speeds, ABS is the way to go. ABS and as much cooling as you want, which sounds kind of totally different to what people usually connect to ABS, no printing, heated chamber and stuff like that. But if you want to print fast, a lot of cooling, ABS is really the way to go. So like printing ABS during a live stream in your basement room might not be like the most comfortable thing. I
do have the ventilation going, so that's something. And I guess I could also use ASA.
Yeah, I wanted to say that. Yeah, it's a bit less smelly.
Or go straight to Prusa PC blend.
Yeah, but then you have it doesn't really smell during printing, but you still have like the bisphenol that is coming out of that.
Well, I could use a bit of extra volume in my chest area.
Yeah, just get some chicken nuggets and you'll be fine.
Yeah.
No. So if you want to print fast, I would probably go for ASA or ABS.
Right.
Did you? I can't really see that from the angle I'm currently looking at you. Did you enclose it already?
No.
Or are the side panels still something that can be installed after like everything is built?
So the build right now, the goal is to get it working, functional, and like to get all the functionality taken care of first, and then we can add on all the petty little details. Like it doesn't have any skirting on the bottom, so. Like the Z-axis gets some really nice decorations and everything down here is closed off. That's not on there. The panels are still missing. There's an air filter that is intended to be added, and a filament guide through the back. That's also not in there yet. This is purely for function at this point. Also because these are the printed forward parts. They do not include all those optional parts that I'm not installing right now. Okay. So air filter housing, all the panel mounts are not included, and all the skirting is also not included. I think that's another like 1.5 kilograms of filament. Maybe a kilogram of filament.
Okay.
For all those optional parts, I guess. So yeah, at this point it is not enclosed.
You have the 300 by 300 millimeter machine. How big is the footprint now? Is it less than 0.5 meter by 0.5 meter?
Yes. So it's 460.
460. Okay. So basically, since, if I, for example, compare it to a Prusa, which has all of the dangling wires on the sides, the desk space you would need for such a machine or a Prusa Mark III are pretty similar. It's just a bit taller.
Not even that. I did mention it on stream once the frame was built. It's like you said, with all the wires dangling out, it's taking up basically the same size, possibly even less, because the bed doesn't move out of the frame. If you look at a bed slinger machine, that is already easily, if you have a 220 bed, 220 on the y-axis, then that's already 440 if you want to reach the entire space of that, which is basically how large that frame is. And for height, the Prusa is about that tall, which you guys on stream can't see. I'm just, that. And then you have the spool mount on top.
Yeah.
So if you use a Prusa as intended, that does take up the same, if not more, space on your desk and in volume if you put it on a shelf or something. So it has a lot more dead space per se.
Yeah.
And this, of course, is 300 by 300 versus 220 by 250.
Yeah. So you actually didn't go like the normal route with an SKR board and a Raspberry Pi and Klipper and things like that. You have a Duet 3 in there. Oh, will you be adding a screen? Because I recently changed the main board of my old Mark II and said, okay, a screen is not really necessary, but because the web interface is really good, and I'm still totally fine with the web interface, but just having my printer not in the same room as I'm usually working and slicing my parts, I noticed that sometimes it's kind of nice to just have the screen and to preheat the nozzle to change material.
Yeah,
and
you do need that.
So and I asked around, and people didn't like the big touch screens. So what I installed on my machine now is a small dot matrix LCD. I can't remember the name anymore. 12064, 128.
12864, yeah.
164. And I'm really happy with that. And it works really well there. It took me a while to find a proper interface file, but then I stumbled upon some random guy, and it works really nice.
Right.
So what are your plans?
So that option of using the 12864 LCD is closed for me. That's not something I can do on this printer because the Duet 3 6HC does not support it. I think the Mini 5 supports that.
But the Mini 5 definitely does.
But the full 6HC does not. So that train has departed. I still have a panel Duet from I don't know when. They sent me that at some point, and I have never used it. I might have. I've not. I've never used it. That would be obviously a prime candidate for an interface, especially for a printer that is basically the highest of ends. As you can build it, that would make sense. Otherwise, if the panel Duet doesn't work out for me, I still have this convertible that I can just slap on. That's a 11.6 inch. If the 7-inch screen is too small, I can just glue that to the front of the printer and have the full Duet web interface open. Though I don't think this is going to be necessary. The panel Duet interface is pretty good. Staying in that same spirit of everything's a bit over the top, everything's a bit expensive on this machine. The Duet hardware is already like I think $350 or something. For the 6HC
do
plus 3HC.
Do you need the extension board? Yeah, exactly.
You just barely need these. So the guys from Duet, they were like, "Hey, do you want some Duet hardware for this?" And I was like, could be cool. And they were like, well, the board we would recommend would be the Mini 5 plus, I think. Is there an extension you can hook up to that?
Yeah, there is an extension. Yeah. That's why it's called 5 plus. I didn't understand that for quite a while. Okay,
so that is the solution that we recommend for this printer. However, because I do have that stuff planned with the I've moved away from that revolving x-axis, and I think I'm now going to do a belt-fed bed system on this. I do need a couple extra stepper drivers and a couple extra outputs, and I'm not sure how much I need. So right now, the 6HC plus 3HC expansion is kind of the solution that gives me the most freedom there.
Yeah. I think, the really nice thing about the Mini 5 Plus is that it's way less expensive than just like the big Duet 3. But the big Duet 3 is, at least in terms of stepper motor drivers, really oversized for basically probably 95% where it's actually used, because those stepper motor drivers, they're able to put out 4 or 5 amps. Yeah.
So I think it's even 6 amps that they would be capable of, but right now they're capped at like 4 because cooling or I don't know what, but they're NEMA 27 sized stepper drivers, basically. Yeah. So overkill for NEMA 17. On the other hand, they work perfectly fine for NEMA 17, and you can use the dynamic current scaling or idle current reduction. I don't know if it actually does dynamic current scaling for higher speeds, but that would be cool. They've got plenty of headroom. They don't need any cooling. I think they even work up to 48 volts.
Yeah,
possibly. Yeah. So that could be something I can look into if because I already know it's like 1500 millimeters a second. The printer is already struggling. So if I do want to push it further than that, maybe try 48 volts.
Yep.
And that could be an option. Yeah. So.
Just something on the side. Speaking of 48 volts, what is like an acceptable voltage level that one as a hobbyist should actually handle? I don't know. Isn't there? Because I know that, for example, basically most of the lab power supplies that you can get are capped at 30 or 40 volts. Isn't there a regulation that, like, if you're going higher, it's not that safe anymore? It's just 12 or 24 volts?
I think there was something with 60 volts where it was like, well, if you get DC under 60 volts, like it's not going to harm you too much. Okay. if you actually get your hands on it and actually have it flow through your chest, etc. Okay. But I can't find any on the fast here. I can't find anything that would quote that 60 volts. I mean, 48 volts is tingly if you touch your tongue to it. AKA very painful, actually. But
9 volts is already probably everyone has already tried just licking one of those 9-volt batteries and see if there's still a voltage.
You don't hold that onto your tongue too long. But yeah, 48 volts, you can still touch that and you're going to be fine. Like you might feel a bit of tensing up, but I think 60 volts or something was a limit. So 48 is like a safe level. Anything above that, I'm personally uncomfortable with that as well.
Yeah. Maybe just as an explanation for the viewers and listeners, why is 48 volts better than a 12 or 24 volts for the stepper motors?
Yes, the question of all questions. So what you start running into with stepper motors or with any motor in general, basically, is let's ignore the entire, it's a switched voltage on the stepper inputs. Let's just see it as a DC motor, basically. So as you supply voltage and therefore current to the motor and that motor starts to spin up, it starts acting as a generator. And the voltage that motor is generating as a generator is inverse to what you're trying to push through it. So at a low RPM, with a stepper motor, for example, you might be fine with a 6-volt supply. That's going to turn just fine and give you the full torque, because it doesn't induce that high of a voltage against what you're trying to push through. But as you try to push faster and faster speeds and it spins faster, it pushes against the voltage you're trying to push through. So on 12 volt, that was actually a problem where you ran out of voltage to drive your motors. So we switched over to using higher current motors versus higher inductance ones. So with a 24 volt system, even as soon as you start pushing those crazier speeds, that voltage that the stepper motor generates starts rising up closer and closer to those 24 volts. And once that voltage is at 24, there's literally no current that you can push through it anymore. So that's going to be a sharp cutoff for how fast you can spin the motor before you run out of input voltage, basically. And the more voltage you have, the faster you can spin it. Of course, there's going to be more power dissipated, which isn't great, but as long as it's just at those short high speed spurts, that shouldn't be much of an issue.
Okay. That's pretty interesting.
Hope that explanation was something that was okay to follow along to.
Yeah, I think it was. I had something like that in mind, but you are more the electrical guy, so better that you explain it. And I think this is something maybe not everyone is aware of, because, well, the switch from 12 volts to 24 volts on like today's printers was nice because you did not need that thick wires anymore for the heated beds, and they were able to heat up faster. But it also has benefits if you want to drive your stepper motors faster.
Absolutely. And of course, if you have that voltage headroom, you're more free to choose stepper motors that are more appropriate for that. For example, those that have a lower rated current but higher inductance, those are more suitable for being driven by a higher voltage system. So because with that higher inductance comes, a greater generated voltage, back EMF. It's also the reason why I need like freewheeling diodes on like switched motor outputs. Otherwise, it blows your MOSFET. That's that same voltage that you get generated there.
Cool.
Yeah. That's the VORON.
I'm really excited first to see it printing, and then what you are going to do with it due to the current hype about speed printing.
Oh yeah, there is that hype. I do. So yeah, speed printing, of course, that's something. I guess we can talk about that at some future time. Is like, how much are we running into the limits of what our mechanics can do? Because from what I understand it, the VORONs very much rely on stuff like input shaping or resin. I don't know what it's called in Reprap firmware, but
it's also called input shaping.
Okay. Or is it called differently in Klipper then?
I don't know. No, I think they're both the same, but I could be wrong there.
Input shaping. So with like corner ringing that you just get if you have fast accelerations, or the extruder not being able to keep up, you kind of need software to make up for that. There's no you're running out of options of what the hardware can provide. Like, you can only make a motion system so stiff.
Yeah.
Yeah, but that might be a topic for a different one.
Yeah, definitely.
Sorry,
yeah,
I keep interrupting you today. Sorry about that.
No, it's totally fine. I'm usually the one that always interrupts. That was actually also the plan for my VORON 0 series, to really find out what are the bottlenecks are to get to my 10-minute benchy, even though that's already totally old now because people are printing like 3-minute benchies, but anyways, I'd be fine with a 10-minute one. I already was taking a look at the extrusion system. So you have the Magnum Plus on there. That shouldn't be limiting right away, but if you are crunching the numbers, even the 50, 60, 70 cubic millimeters a second that thing can extrude.
This one's rated for 90.
That's okay for 90. With a 0.4 millimeter nozzle, that might be fine for quite a while. But if you're saying, okay, I do have the print space now and I want to print big parts fast with a 0.6, 0.8 millimeter, 1 millimeter nozzle, it's not too much. Yeah. And I was also asking myself, okay, when the hot end is capable of like just melting that amount of plastic, at which point is like the feeder, the extruder, the weak point, and it's just not able to spin that fast anymore. But yeah, it's a really interesting topic, and I think it really helps us to understand where bottlenecks are and what are ways to fix them.
Yeah, I guess one thing that helps is when you have a hot end that actually fully melts your plastic and you don't have to work against like half molten plastic trying to be pushed through the nozzle, that does take off some load off of the extruder. So that helps. But let me see. So the VORON now has that. I think it's the afterburner extruder, right? That's the standard one that they're using, and it's probably going to be limited by the motor that's on there. So it's a pancake style stepper motor, supposedly 1 amp rated. I don't think we can install a larger one because that pushes back the drag chain mounts and all of that, because that attaches literally to the back of the motor. So I don't know how much headroom there's going to be there, but we shall find out. I'm still
not the greatest fan of a direct extrusion system on a high-speed printer, just due to the added weight and then the compromises you would need to do terms of input shaping. Yeah, but input shaping, you still have a mass that you need to move and to accelerate. So even though there is now the VORON 0.1 released, which also comes with a small direct extruder, I will not be using the direct extruder because I think for a fast extrusion system, you need to get all the weight possible available away from your print head. And if you have a well-tuned Bowden system, it still can perform quite well.
though we do kind of need to look at this from the other options. So there is a Bowden head for the VORON 2.4, of course, for the afterburner. I believe this is. You can just replace the hot end mount and all that with a Bowden adapter. However, where's my table? What I'm worrying about is that input shaping thing again. Linear advance, aka, is where you do have a bit more lag and a bit more
input shaping and linear advance are two different things. Pressure advance and linear advance are comparable.
Okay, terminology.
Sorry,
but it's yeah, you're right.
Yeah. Right. So linear advance and pressure advance is basically tuning the extrusion system to not over and under extrude during accelerations and decelerations. Input shaping is working on the motion system, and
because the extrusion system is one that has a dampening to it. It has a lag to it, whereas the motion system does not have that. It only has that spring component, and the stepper motor is always accurate on the motion system. It never lags behind. Okay, what I'm trying to say is I guess it's technically it's also input shaping, right? It's just the terminology is different. Pressure advance. Let's call it pressure advance for the extruder, because with faster print speeds on a Bowden, you're still going to need to slow down and speed up the material flow in your hot end quite quickly. The longer that Bowden system is, and the longer that lag is between your extruder doing something and that springiness actually dissipating into the hot end, the more you're going to have to work against that and do pressure advance for getting crisp prints. Otherwise, with a Bowden system, you're just going to run into like those bits of under extrusion at the start of an extrusion line and then over extrusion where you slow back down. So you will need to do even more compensation for that.
Yeah.
Now on the pressure advance side, not on the input shaping for having a heavier extruder. So
that might make 3mm filament more feasible again, because that's stiffer. But
though with 3mm filament, it goes both ways, because with the larger filament, also smaller deviations in length make up for more volume. So it basically cancels itself out. And from what I've heard with E3D, like 1.75 for those applications is better.
Okay. It's a really interesting topic with, well, many different ways how you can approach that problem, and some might be better than others, and the solutions might not be obvious right from the beginning. So it's really nice that we're trying to dig more and more deep into that, because that just helps us understand those problems better.
Yeah, and one thing I talked to Buddy about yesterday is like, it's nice to see that we are at that point where we have, what's the word? We have used up all the possibilities that the current set of options we have gives us. Like, we brought up the Mark III. Like, the Mark III is a fine printer, but it doesn't use input shaping. It doesn't use many. It does have linear advance now, but it doesn't use many of the more advanced software features that we now have. It very much relies on software to make the experience good, but it's almost an artifact of the best we could do a couple of years ago. And now with stuff like the VORON, and I'm sure there are going to be commercialized printers that make use of those same ideas, they can now deliver more than what was possible just a couple of years ago with the learnings we've taken and with the more advanced options we have in firmware now. Yeah, that was fantastic to watch.
Cool.
Okay, we said this was going to be a shorter one because you have to cook dinner in a minute. So let's move on. We're famous.
Yeah, let's move on. We're famous.
Quick one.
We're famous. It took me quite a while to find the article because it was like on the page before the last page. Vorletzte Seite. What's
second to last page? Yeah.
Second to last page. But yeah, everyone who is watching at the moment on YouTube, There is an article about the podcast in the latest Make magazine.
Can you actually show insides of the magazine, copyright and stuff? Do we need to blur that out? Or is that... It wasn't legible, but we're just going to say, otherwise it would be like fair use. But you've already shared it on Twitter, so too late.
I already shared it on Twitter, and even Make Magazine Germany retweeted that, so it should be fine. I haven't shown everything, so that's just a small teaser. I don't know if it's comparable to a teacher is only allowed to copy like 5 or 10% of a book, otherwise it's copyright infringement.
We have the new fair use laws. It's like, what is it, 15 characters that you can use?
Something like that. If you want to read about it, buy the latest Make magazine, so we should be fine again. No,
it's an ad.
It's nice to be mentioned in a German magazine. They say right at the beginning that this is an English podcast, but I don't think they somehow mention. Yeah, it's kind of weird that two German guys whose native language is German talk on a now almost 50 episode podcast in English, not in their native language.
We're going full circle. Two Germans talking in English, being featured in a German magazine, saying that they're talking. So it's only Germans involved at this point, but we're talking in English. So weird.
So still happy about every non-native English speaker that is listening or watching to us. Yeah, and we're famous now. We're now featured in a print magazine. It's really old school.
It's going, weird how times change. Where it's like, well, now the print magazines report on us and think that's something big. Well, we probably have more? Do we have a larger audience than Make Magazine?
I was wondering how many prints they have for the Make magazine. I would almost assume, but I didn't find any numbers for that. So
Wikipedia says 36,000 Auflage, but I don't know how up to date that is.
Okay.
Okay, so they're a bit bigger.
Yeah.
But not necessarily bigger than the audience of a YouTube video that we put out, so.
Yeah. So I checked our YouTube stats from, I think it was released, on Saturday, I think it was released. There wasn't a big spike of new subscribers to our podcast.
What do you expect? So with us being about the same size of an audience, I guess we should now report on Make Magazine and kind of give a quick description of what they do.
Yeah.
And say, hey, by the way, that this is a magazine that does projects, and I don't know what else to do. I'm not subscribed to them.
Making projects. Not primarily 3D printing, definitely not, but I guess the connection between electronics, Arduino, programming. I really enjoy reading it every 2 months when it's released. And this is something that I, for example, take with me when, I don't know, yesterday we were at the Lake Constance having a nice time outside and just do some casual reading.
Yeah, basically Hackaday in pictures. Hackaday in a printed form.
Yeah, is there? I guess there's of course there's an English magazine as well. So
yeah, of course. Yeah. So that is us being featured in Make Magazine. Cool. Should we ask them if they want a Beleg exemplar of this podcast because we mentioned them?
Maybe we could ask them. Yeah, all right. Let's maybe continue with other, kind of German news. Yeah, it's German news.
Absolutely.
So, there is, I don't know the English name, but in the US and probably in all other countries, there's something similar. So in Germany, there is Jugend Forscht, which is roughly translated, the
youth sciences.
Youth sciences.
Science.
Because we don't have something like science fair. Oh, how is it called?
Science fairs.
Science fairs. Yeah,
we don't have
Jugendforsch.
And we don't have an equivalent of that is like accurate. Maybe some schools do. But so Jugend Forscht, for those of you who are not familiar with the concept, it's basically a competition, more or less, done annually where young scientists, inventors, create something, and then it's an event you actually get together at. Every project has their little stall. It's kind of like poster sessions in actual research science and in proper science. So it's maybe a light version of that, and everyone presents their findings, and has a little booth. And at the end of the event, there's several awards for, hey, this is like the Eco Award, this is most innovative, and this is like the top 3, and you get a little award for presenting your stuff. I've actually been in those a couple of times, and that was fantastic. Not with the most fantastic projects, but just as a student, how old was I? 13, 14, 15, something like that. I even though my projects were garbage, it puts you on the track of, hey, this is how you science. This is how you collect data. This is how you make stuff reproducible. This is how you present stuff. It just basically puts you through that entire process, and you get to learn and experience that at your own pace and with stuff you might even care about, which is amazing. I think it's a great incentive and a great project. So, Jugend Forscht, there has been one of the projects shown is a now patented heating and dispersion system for resin via ultrasonic. And you've said you've taken a quick read through the article.
Yeah. So this guy has been improving
Tobias
a resin 3D printer.
He has a name.
Tobias Neidhardt. Try to improve the resin 3D printing process by having ultrasonic emitters around the resin vat to, for once, heat the resin, because if it is at usually a bit higher than ambient temperature, around 30-40 degrees Celsius, it polymerizes faster, it flows nicer, it's just better for the printing process in general. And also the ultrasonic helped him to disperse additives and the photosensitive ingredients and all of the stuff that is in the 3D printing resin better. And he was therefore able to was able to prove that using this approach gives him faster prints, more reproducible prints, and even stronger prints in the end. And I think it's a pretty neat concept, because I have been experimenting with resin prints in my basement where it's always cold and it is always a hassle. So I even built it kind of a heated chamber, put a heater inside. But just having something like that integrated in a resin printer, I think is a really nice upside. And also the dispersion part is interesting, especially thinking about one of your latest project that you did, where you tried to add glitter and other particles into your resin.
Back there.
And you definitely had the problem that they went out of suspension. I can see that.
Just pointing them out for the viewers.
So these are visual aspects, but also anyone who has maybe made the mistake to have a resin bottle and just not really shaking it or moving it around, before pouring it into the vat might have noticed that the resin is not properly working anymore. And having having these ultrasonic sensors disperse the resin or the ingredients of the resin constantly, just makes it more reproducible, or the process more reproducible.
Yeah, it's not sensors, it's actual ultrasonic emitters that kind of shape. Okay, but it's already patented. So are we actually going to see that anywhere? I don't know. So it's always saying his patented main innovations. Maybe some printers who can afford that or who manage to license that somehow.
I don't want to dig into the patent thing again. But it is kind of unfortunate that something like that, well, at least he seems to have applied it for a patent. But that's just how it goes.
Yeah, but that's that. So ultrasonic. We'll see.
Nice idea. We won't probably see it in the future.
Oh well. What we will also not see is the Torshn Kickstarter that we talked about last time. I think we're a bit late on these because they happened between episodes. So last episode we talked about, I think it was last episode, we talked about the what's it called? Labicon? Astro Labicon. The Astro Labicon by Make Anything. Which is that puzzle that you twist and turn and you push the colored balls around, you sort them. It's a simple concept, and it looks like the Torshn Kickstarter has been suspended. Of course, they claim some BS reason why it was suspended in the actual official update, but
it was suspended by Kickstarter. But I think that was already during the Kickstarter, but those torsion parts were already available on AliExpress.
Yeah.
So maybe we will see Torshn in the future, but
I think that was
on a Kickstarter.
If I remember correctly, that was the reason why they were suspended, because it's not something new, because the parts are already available. I think that was the main reason for that, actually.
Okay.
So obviously you can still buy them on AliExpress, and I don't know if it's actually, if the Torshn, we don't know who's behind Torshn, if that is just literally the same group of people putting up a Kickstarter that are already selling it on AliExpress. I don't know.
Yeah,
could be.
I just need to check Torshn. Yeah, it's even sold under that name. Plastic UFO-shaped spinning Torshn puzzle game with color beads, fast speed cube.
It's sold under that name on AliExpress?
They have it in the title. Torshn puzzle.
Yeah. They
show the Torshn puzzle with a toddler. I don't know if it's a good idea to give that magnetically held together puzzle with those beads to a toddler, but that's something different. So it is available on Kickstarter. That seems to be the reason why it's
on AliExpress.
It was suspended. Sorry.
Yeah.
But the Kickstarter got suspended. Yeah, just a small update here.
Okay. Well, it's good to see that, stuff is sometimes working as intended, and at least it got suspended. Fine.
Yeah.
And you put another Kickstarter in here.
Of course, always Kickstarter.
We don't really love Kickstarters.
Yeah, we love Kickstarters. But I think this is not the worst.
Oh God. You're setting the bar pretty low for this one.
So, 3D printed bike helmet, which goes under the name Kai. I think Kai.
Kav?
Oh, sorry. Is it? Oh, yeah, it's Kav. So there is a Kickstarter for a 3D printed bike helmet. I think it's currently still going on, but that's not the reason why we're talking about it. I just found it on a news site. But the reason why I put it in there, because I thought for once, 3D printing a bike helmet is not the worst idea. Because customizability, you can print it perfectly fitting to your head. If you need that in the end, is a different question, because like the adjustable ones are also pretty comfortable. And then the thing that 3D printing gives you the possibility to, for example, adjust densities, adjust infill structures at certain areas of a part, gives you the possibility to tune the properties of such a helmet just like you want it to be, to have it maybe hard in one direction, but really impact resistant or impact absorbing in another direction, which is pretty nice.
So this is specifically a bicycle helmet. I guess we need to point that out. It's not a motorbike helmet. And what a bicycle helmet needs to do versus a soldier's helmet, for example, it's not against protecting. It's not for protecting against like bullets coming your way, which would a steel cap would maybe do. But it's literally just if your head hits the pavement or hits a tree or something, it kind of distributes those forces around and kind of gives you, instead of like smashing your head in, it distributes it around and just gives you a concussion, best case. So what I see is, so typically the way a helmet is built, it's a styrofoam core that is molded into shape, and then it's I believe it's a Lexan polycarbonate sheet over top to keep it from cracking on impact. So the Lexan sheet gives you that strength basically on the outside as a shell, and then the styrofoam, the EPS on the inside, gives it that malleability that your head can kind of cushion into, and it also gives it its shape and kind of it's a half sandwich construction that allows your head to bump into stuff without it getting smashed. So how does that cav helmet do that with just being printed in TPE? It's like strapping it doesn't have that hard shell on the outside, right? It's like strapping a pillow around your head, which I guess can work too, but it's a rather thin one.
Yeah, why not? It always depends on like the thickness you're designing it. As I said previously, I think just using the possibilities that you have with 3D printing, you can make it kind of hardish. Well, they're using TPE in certain areas, but still flexible in other ones, so that an impact is dispersed over your whole head, and even you have the springiness that you don't get these high accelerations on your brain. But also the TPE, well, it doesn't require that outside hard shell, because in itself it's already a really tough material that does not usually crack.
Well, you don't care about the cracking per se. You know, if it cracks, like a typical bike helmet, you have one impact on it, you're supposed to throw it away because there might be cracks in it that make it weaker next time. But when something cracks, it actually absorbs energy. That's something that crumple zone essentially. So what I'm seeing with the TPE, of course, it's a nice cushion. But say you hit a light pole, you hit something that is, or a small tree or something that has like a very concentrated impact spot. The polycarbonate shell on a traditional helmet that would disperse it. I don't see how that would be done with the cav helmet that is just one single material that's all semi-flexible.
So I'm not 100% sure if the polycarbonate that you, for example, have on a normal bike helmet is really that important for the structural integrity. I think it's more for the visual appearance, but it's just like not even half a millimeter thick sheet of of plastic that's on the outside usually. If I, for example, take a look at my helmet.
Yeah,
and
they're very thin, but you need it for that semi-sandwich structure. That's what holds the EPS together, styrofoam.
Yeah. Okay. Yeah. But since the TPE, even though it's a bit soft, it still has some rigidity, and if there is a certain thickness, I'm quite sure that it might also be able to absorb a more more directed hit on your head pretty well. But this is also something I put into the show notes. How about safety? At least I think in Germany, if you want to sell a helmet, it needs to be certified in some way, and there are some scenarios that need to be tested.
Yeah, that's something I'm just missing from the Kickstarter entirely. Any sort of testing, any sort of results that would give you confidence in this thing actually working. Because sure, it looks nice. Yeah. Sure, it's customized, but if it doesn't actually do its job, I would just want to see something that proves that.
Yeah. Also concerning safety, if like the general concept works or doesn't work, what I also ask myself is, well, now you're producing safety equipment with a 3D printer. What kind of quality control do you need to do that if you're producing 1,000 of helmets, you can be sure that none of them had, well, like in between a clog in your nozzle or a clog in your hot end, which, for example, weakened the layers. And how can you make sure that something like that is not happening? Or would they need to do that? Should they do that? Is that something that you would directly see from the outside? But this becomes really interesting if you are thinking about really, safety equipment, not just like a bracket that you have on your wall where your code is hanging.
Yeah, that's. I think we've talked about that a couple of times before. It's like the automated inspection and quality assurance part of a 3D print. I mean, do you have a visual-based system where you take a photo of every layer and compare that against what it should be looking like? Do you have, X-ray? I don't think you can do all that much there. Do you do a CT scan on every single part you print?
It's too expensive.
You could do that, but it's too expensive in the end.
No.
Just something that, for the most part, 3D prints are reliable and they're fine, but it's about that one case where it's not. And you do need to catch it, especially in stuff that's like protective equipment that's supposed to keep the user safe. Or, like you said, in stuff that's not just a bracket. Like, is it Boeing that's printing like terminology? The one of the bracket parts that has like the runway wheels of the airplane, kind of one of those flip up bits, a bracket, titanium bracket, landing gear, something in there was 3D printed, and of course that is something that is kind of safety critical. If you land and that thing just breaks, you've got a couple hundred people, worst case, in that plane that are going to be put in a quite risky situation with the plane grinding along the runway. It's not something you want to have happen. So that is something that I guess they have figured out for that, but it's not, quality assurance is not something we have for the wider range of 3D printers at this point. So,
well, I know that there are ways to do that for like more professional 3D printing. Just metal 3D printing, there are online monitoring system where you take a look at like the heat distribution of each layer. You make pictures of every layer. You do X-ray testing. You do CT testing. You do penetrant testing for aerospace parts. But there are barely any things in that direction that I have seen for FDM 3D printing. This is something that will become more and more important, especially for things like that. But I think something like that is totally necessary, because you can't have one of 1,000 parts fail due to the nozzle being clogged, the filament not being fed properly, and everything that is connected. Can you always be sure that you see flaws on the outside? So I hope they figured something out in that direction. I hope they're doing some quality checks, because I am definitely sure that something like that will be necessary if you are selling such a product, especially at such a premium price, because I think the normal
$350.
I think that's just the Kickstarter price.
Yeah, so it's $285 for the super early bird, which they're saying is $90 off of MSRP. So it would be $375 US dollars plus tax and shipping for the Cav R1, and that they're saying that includes a fit session. So I don't know where that will be done.
In sunny California.
Yeah. So it is only sold in the US, where, I don't know, safety regulations for bike helmets might be a bit more lax, because, as long as it's not a car, they don't really care about it. But US only at this point. Premium product. I would like to see some sort of proof that it actually is functional. That's my biggest concern with it.
I'm quite sure that they did some testing, and just below like their stretch goals, they show a picture of like this generic head that is bounced off a part of infill structure, where they said we use our impact data to inform helmet offset, vent placement, and design. So they definitely did that. But yeah, it's a premium product, and as I said, I put it in here because I think it's a feasible application. It's customized fit. It's using infill structure in a way that, is best suited for the application, and you wouldn't be able to do that with like another conventional manufacturing method. So,
right.
Pretty cool.
Pretty cool. I mean, it's always nice to see new applications. Okay, we're at 55 minutes. How much more do we want to do?
Let's put that into the next one.
So I guess we're moving into the Q&A session then, into this Q&A segment. That's 4 questions basically. And the first one is a tweet at you and me. Maybe next time include at the Meltzone so we can find it a bit more easily. Millen is asking, hey, any idea about the capability of resin prints against the water leakage, say as a lid on a container submerged in the pool? I know FDM prints would be poor. So, first of all, are FDM prints poor for water leakage?
They can be poor. I think everyone who has already printed a vase and tried to fill it with water, probably in 60% of the cases, there was a puddle of water below that vase quite after you filled it. FDM 3D prints can be kind of tricky to get leak-proof and waterproof and even airtight. There are methods to do that, but let's talk about that in a second. Resin 3D prints. I would not see a reason why resin 3D prints would not be watertight. Of course, they have the problem that the polymer itself might absorb moisture over time and not be like totally watertight, but I think it would be in a similar way watertight as your Tupperware box.
Pretty much, yeah. I mean, it's a different type of polymer, but there's no... It doesn't have any porous structure to it, right? Unless an FDM print possibly could have. It is, by the way, that the process works for resin prints. There is no technical way that you could have, except maybe a bubble, but that would be so microscopic that it's just, you always have a bit of thickness. There's like no way that a resin print would not be watertight in the traditional definition.
Yeah.
So that totally works. Now for FDM, I think the biggest reason for parts not being watertight is, start-stop of a layer. Of course, that leaves a tiny gap possibly. But also a lot of printers are configured to under-extrude by less or larger margin. So it's quite common to see like 5, just by default, 5% under extrusion. And that, of course, allows for that allows for more gaps to be introduced and not being filled, because it is, to a point, if you slightly over extrude, it is cumulative over the layers. So if you have one layer that is slightly over squished, your next one already has that extra material to work against, and that kind of builds up. So if you slightly over extrude, you are very likely to get something that is totally watertight. Also wide extrusion width, which kind of does the same if you're doing vase mode. So.
Yeah, that also worked pretty well for me in the past. Then there are pre-processing methods. Vapor smoothing.
Post-processing?
Vapor smoothing, I think, is definitely a feasible option. If you're having PVB or polysmooth filament in IPA vapor, isopropanol. And for ABS, ASA, acetone vapor, either, vapor or just dip it in there or brush it on. That's an option. Resins would be an option, just covering it in either epoxy resin or
SLA resin also works.
Or even SLA resin.
Yeah,
people have been using that.
I've done that before. You smear it on, you hit it with some UV light, and it cures on as a solid layer. You have plenty of time to work with it. So that's a nice hybrid approach. Though those methods always add a bit of thickness to your material, so you have to account for that in the design stage.
Yeah. Salt remelting. So I did some research in that a while ago, and it's a really interesting method. If I find more time, I need to dig deeper into that. But salt remelting basically means that you embed your FDM 3D print in really fine salt powder, heated above the melting point, the layers, and also porosity. And I think it's not that much porosity in the terms of a circular or a spherical pore, but it's those small cracks and small, I don't know the English term for that, but where basically the ends of
joints.
Two printing lines, the joints. With salt remelting, you melt everything together into a big blob. The salt helps you to still retain the shape of the part. And that is also a possibility to make your parts watertight and even airtight. So the guy who did the video right after I think I did my first experiments remelting in plaster, he said that he used that technique because he wanted to have airtight parts. So seems to be well working. Also an option to get watertight parts in the end, but it is definitely more work.
For sure.
Maybe even concerning the question in the beginning, if you have a container that you want to submerge, of course your parts could be watertight, but the problem in the end could be the connection where you screw on the lid. So you need to make sure that you have a proper sealant there. Either use a gasket, or
if it's a container submerged in a pool, gasket. You could even print a gasket, right? That also works with TPU, or just use silicone or some other stuff if it's okay, if it's not unscrewable, removable, if you can't undo it, if that's fine.
I think that answers that
pretty much. Bobby has a comment about the Siraya Tech sponsorship. Bad thing about them is that they're not selling in the EU, and they are. Stefan, you checked on Amazon?
Yeah, I checked Amazon Germany. There were offers for at least the blue resin. Honestly, I have never purchased Siraya Tech resin myself in the EU. But you also said that Siraya Tech is shipping to the EU, or might even have a stock in the EU somewhere. Yeah,
they have I might need to look this up, but they do directly sell to you, and often have more stock than Amazon. And they also have all the varieties of resins available on their own stores. I think they definitely ship from China pretty quickly, but they also might have a EU warehouse.
Yep.
So that is a backup option if you can't find it on Amazon. The thing with being an influencer is you rarely buy the stuff you're working with because companies are pretty good about sending out samples. I have more Siraya resin. It's usually taking way less time than if you would like order it yourself with standard shipping. Yeah. Well. And then lastly, Kim Ravn-Hansen is asking about specifically our experience with the Duet boards versus the between the big Tree Tech Reprap firmware compatible boards, which apparently have some issues with upload speeds. And this is all I ask for. Okay, formal review would be nice. Perhaps sometime, but basically asking about how usable is the Duet set of boards for using it without Octoprint, for uploading stuff to the printer itself through Wi-Fi, uploading G-code files. And from my experience I have a Duet 3, the full 6HC in the VORON 2.4, but I have worked with Duet 2 in the past, Duet Wi-Fi. And those have been totally fine. The upload speeds are fine. Printing from the I guess it writes it to the SD card. Yeah. Printing from that is fine. It's as quick as it needs to be. I think it's not quite as fast as uploading to Octoprint, but that might just be a difference in process speed. But really, it's fine. On the genuine boards. I have also I have been working with the Duet 2 and the Duet 5 Mini, and there it's totally fine. So I guess upload speeds 500 kilobytes to 1 megabyte a second on normal Wi-Fi. I am currently working with a Mellow 3D Reprap firmware board. I need to, what's the name? It's the Mellowfly. Oh, damn it. It's the Mellowfly CDY version 2 board that I'm currently putting into one of my old CNCs. And that also runs Reprap firmware. And even though I haven't uploaded that much yet, I noticed, or I had the impression that it was a bit slower than with my Duet boards. But I gotta say that CNC is currently in my basement, and the next access point is a floor upwards, so that could also only have been a bad Wi-Fi connection. Yeah. I hope to release a video on that at some point, but at least for the Mellowfly boards, it says that they can do like around 500 kilobytes per sec. Is that kilobytes or kilobits? Is it a uppercase or lowercase b? It's in Reprap firmware it says an uppercase b. Okay, and it should be bytes. Bytes, yeah. 500 kilobytes per second. Yeah, I need to check that. Don't know how it is with the big tree Tech boards, but at least it seems to have been working. And also with the Mellow 3D boards, using Reprap firmware on them so far seems to be really straightforward. And it's a really nice experience just to have, again, just like with the Duet boards, the web interface directly integrated on the main board, and you don't have to fiddle around with with the Raspberry Pi, with power supply for that and USB cable and everything. So one thing I learned in the stream yesterday was that you can actually integrate a webcam into the Duet web interface. And I was like, you can. What doesn't have USB? Like how? But basically, you use a security camera that gives you an HD web feed, a regular video feed, and it basically just displays that feed in the web interface. So that functionally makes it for the most part, like for the basic stuff, that makes it a full replacement for Octoprint. Of course, plugins, Octolabs, Spaghetti Detective, all those things you can't use with Duet without having a full Linux system, more or less. But for like basic use, that makes it a full-on replacement.
And it's super snappy.
Yeah, because it runs directly on the printer's hardware. One thing that I always dislike about doing Raspberry Pi projects is the fact that you power it off wrong a couple of times and stuff just stops working. Or I guess on any Linux system that you do updates to, it's always like, well, it works fine for a couple of months and then all of a sudden it starts having issues and it stops booting. And I've always had that on everything that I've had a Raspberry Pi for. For example, that info screen, that portrait mode LCD info panel that I have on the wall, worked fine for a year. All of a sudden, the taskbar is gone in the, I think it's LXDE, Ubuntu. Taskbar is gone, so I can't actually access Wi-Fi settings. I have to do that through the terminal. And why is that happening? I didn't do anything to it. I think I just ran updates on it once, apt-get upgrade. And all of a sudden, stuff is breaking. I have powered it off, a bit rough once or twice, but if you have a power failure, there's nothing you can do. I always try to shut it down cleanly. It's like, that doesn't happen on Duet because it is a read-only system for the most part. It has its config and that's it. It doesn't have any system files that could get corrupted.
In defense of Octoprint and also other things running on the Raspberry Pi, so I have a media center down in our living room, which I always power out by just pulling the plug. I've been using that for 2-3 years. Still fine.
Okay.
Didn't kill it so far.
So is that there is a way to do a Linux setup where there is literally just a fixed system image, and then you have an overlay of all your temporary files like log files and your configs that maybe get loaded in once, but the system itself stays the same. Do you know if that's one of those?
I'm a Linux dummy, and it's just a standard install of XBMC. Didn't have any problems there. Even all my Octoprint instances never broke down. And I basically never shutting Octoprint down and then turning it off. I always just pull the plug on my VORON, on my old Prusa and things like that. So far the experience has been pretty good. But one thing maybe that I'm doing, I'm usually using quite high quality SD cards. I don't know if that changes anything. But so far so good.
Must have just been my luck then. Yeah, I would like to use the Raspberry Pi more, but that's always been my experience. Like, if you don't pull a backup, like kiss your project goodbye after a couple months, and that's just a bit frustrating. Yeah. Oh well.
Maybe just as a last comment before we say goodbye for today. One of the main reasons why I dislike working with Raspberry Pis is supplying it with power. That's just maybe only the laziness of me, but if you're trying to power a Raspberry Pi with a phone charger, that doesn't properly work. You need to have a USB power supply or directly power the Raspberry Pi via the pins. That works very well and totally reproducible. But so many times, and that's totally my fault, I tried to run Octoprint and everything just with a phone charger, which should have the amperage, but a phone charger is not a power supply. So everyone who has problems,
technically it is a power supply. Technically it's just a 5.2 volt power supply. What I have had really good experience with as far as powering them goes is not necessarily the charger side, but yes, also the charger side. Just getting really high quality USB cables. So the ones I really like are Anker Power Core Powerline. They're not that expensive actually. like $5 for a decent cable, and you can get them in 3 packs. Those have always worked great for me. I use them in the studio everywhere. They're fantastic, and Anker also makes the chargers that go with it. So I'm using like the black, just the standard. I think it's a 3 output, 3 or 4 amp per outlet supply, and those have been working flawlessly for me. But really, the biggest part is the high quality USB cable. And just because the cable is thick doesn't mean it's got proper conductors in there. It might just be thick insulation. So yeah. Get decent USB cables. Are you using brand name cables or just whatever comes with your phones?
No, I'm usually trying to use decent cables because I know that if you're using not proper cables at those amperages, the voltage just drops to a point where the Raspberry Pi is not happy anymore.
Okay.
And for this reason, I think if you're so I don't know, I think a normal phone charger does output 5.0 volts, but the Raspberry Pi power supplies, they usually put out 5.1, 5.2 volts.
Yeah. Well, most phone chargers are just by default 5.2 because they account for a bit of voltage drop in the USB cable. And I think the USB spec is also allowing that to be a bit over. ATX spec, I think, is even 5% computer power supplies, but might be similar in USB.
Yeah.
So yeah,
okay.
That's it. I think that's the shortest episode we've done in a year, easily.
It is 2 weeks after the last one.
Yeah. Oh yeah, best cadence too. So let's try and keep that up. And my mom does all my accounting and sponsor deals and organizes all that for me for the last couple of years. And she was like, "Why didn't you tell me about the fact that you're recording the next one so early? Like I could have looked for a sponsor for this one." Like, oh, sorry, I guess we're not having one this one. Yeah, but yeah, let's hope we get the next one in just as quick again. It's been fun. Quick podcast. Not burned out after this one. Let's keep it up. All right, Stefan, thank you for the time.
Thanks for yours.
Thank you.
Thanks everyone for listening
and watching.
If you want to support us, check out our patrons down in the show notes. And yeah, I guess see you guys in the next one.
See you. Bye.
Bye.